Hi everybody. In this video, we're going to start solving equations, and I'm going to break the process into a few different videos. And we're going to start with the easiest forms first in this first video, and then progressively get into the more challenging examples. So you will see multiple videos on how to solve equations here. So in this first video, we're really going to go through some of the key definitions and really more the one-step, maybe two-step equations. So your more simple forms here. So a couple things first. And we've seen this definition already, but you want to just recall that what we're looking for here, we're looking for solutions, right? So a solution to an equation is a value that makes the equation true. And you want to just remember here, we're going to go back to equations now. So when we're dealing with equations, this is when we have one expression equal to another expression. So the key thing is you have some sort of equal sign in your equation. And we're solving for an answer. We're not just plugging in values and evaluating. We really want to find the value that's going to make it true. And you're going to see that for our purposes, most of our examples are going to have just one solution, but there are examples that have no solution or many solutions. So we'll talk about that later in the course. But for most of the time, for our purposes, you'll see that your equations are going to have one solution, at least now in these beginning examples. So let's consider the equation 2x plus 1 equals 4. Is x equals 3 a solution? Now, we've already seen this before. So think back a few videos how we did this. And you want to remember to check this. What you do is you plug in the solution and see if it is true or false. So if you get a true statement, then it is a solution. And if you get a false statement, then it is not a solution. So going back to my example here, I take 2x plus 1 equals 4. I'm looking at x equals 3. So when I replace that x value with 3, I get 2 times 3, which is 6. 6 plus 1 is 7, and 7 equals 4. Obviously, this is false. This is not true. So x equals 3 is not a solution. Now, it's great here to be able to plug in values and check if they work, but obviously we don't want to always do this. This takes a really long time to just guess at random numbers to see if they work, particularly as our equations get more difficult. So our simple equations, some of you may be able to just kind of look at and figure out with a little bit of trial and error what the answer is, but as our equations get much more complicated, you're not going to be able to do that as easily. So we do want to have some sort of systematic way to go ahead and solve. And we do have a few properties that we're going to look at. I'm just going to get a fresh page to start on. All right, so our first property is called the addition property of equality. And what it says is that if A equals B, then A plus C equals B plus C. So what does that mean? That means that if we add or even subtract the same number to both sides of the equation, it remains true. So the solution will not be affected. So basically it says that it's okay to add or subtract the same number to both sides of the equation. Now, why is subtraction also included? Subtraction is included because subtraction is the same thing as adding the opposite or adding the negative, right? We always switch subtraction to addition. So it can get included in this statement as well here. So basically what it says is if something starts off as equal, then adding the same number to both sides or subtracting the same number to both sides is totally fine. It's not going to mess anything up, and we absolutely can do that. And we're going to use that property to help us solve equations. So for example, let's solve the equation x minus 4 equals 5. And I do want to note that to solve, we want to get the variable alone. This will give a result then of x equals a number, for instance. So our goal is to get that variable by itself so that we actually can find our solution. So x will equal the number, and that will be our solution. So I want the variable to be by itself on that side of the equation, and I want this minus 4 to go away. So when we're solving equations, you sort of really want to think about opposites. If I want a minus 4 to go away, well, the opposite of minus 4 is plus 4. So what I can do here is, and I'm actually going to just draw like a little line at my equal sign just to show my two sides of the equation, is I'm going to add 4 to both sides. And my property says it's okay to do this. I can add or subtract any number I want on both sides, as long as I do it once on the left side and once on the right side. It will keep the equality true. So what happens here on the left is negative 4 plus positive 4 is 0. It's going to cancel out, so that is gone. And what happens is I'm left with just the x. Now on the right, 5 plus 4 becomes 9. And notice how my answer is now alone. I can check this by plugging in to make sure I haven't made any mistakes. So if I plug in x equals 9, I get 9 minus 4 equals 5, and 9 minus 4 is actually 5, so this is true. Let's do another one. This time, let's solve x plus 2 equals 5. And again, for myself, I like to put just a little, I'll do it in purple, kind of vertical line right on the equal sign. I'm not making it a not equals. I'm just doing it for myself to guide myself so I can see those two sides of the equation. If you find that helpful, do that as well. If you don't find it helpful, that's okay. You don't have to do it. But I find that students sometimes have trouble keeping track of their different sides of the equation, or things get messy. And that way it just kind of reminds you to stay organized. So again, I want the x by itself. So if I want the x by itself, I want this plus 2 gone. It needs to go away. And the opposite of adding 2 is subtracting 2. So that's how we can make it go away. So I'm going to subtract 2 on both sides. Now 2 minus 2 is 0. So that part actually goes away. right? Because if we're adding 0, it's not going to change anything. And then on the other side, 5 minus 2 is 3. So there's my solution, x equals 3. Now you can check this as well. I'm not going to plug it back in. You can do it mentally. 3 plus 2 is 5. So we know our answer does check out here. Let's do another example. Now my variable is on the right this time, but it doesn't matter. So again, I'm just going to kind of draw that little line just lightly there to help me stay organized. And I want the y by itself. So when I say by itself, I mean alone on that side of the equation. So I need to get rid of this plus 4. Well, the opposite of plus 4 is a minus 4. So I'm going to do minus 4 on both sides. 4 minus 4 is 0, so that cancels out. Now on the left here, you have negative 6 minus 4, which is the same thing as negative 6 plus negative 4. So you can do it any way you want in your head. Just remember that a subtraction sign and a negative are basically the same thing. So we're adding these two negatives here. Negative 6 plus negative 4 is negative 10. And I'll do this check because this one's a little bit different. So I go back to my original equation, and I'm going to replace it with negative 10 for y. Now, negative 10 plus 4 is negative 6, so this checks out. Notice that it doesn't matter which side my y is on, or my variable, it's the same thing. Negative 10 equals y, or y equals negative 10 is the exact same thing. So you can change that order at the end if you like. Got my word solve. So here we're going to solve again. Now, notice this one's a little bit different. If I draw that line, I see that x is actually already by itself. I don't have to move anything, which is kind of nice. So if your x is already by itself, you're just going to leave it alone, and then I will just clean up the other side. So negative 5 plus 4 is negative 1, plus negative 3 is going to be negative 4. So in this case, that one's much easier. You only have to cancel things if you need to actually cancel something out. If x is already by itself, then we don't need to do that. All right, so let's do the other property now. So now we're doing the multiplication property. Of equality. And this actually basically says the same thing. It says that it's going to be okay to multiply or divide on both sides of the equation, but we'll write it a little bit more formally. So if A equals B, then AC equals BC as long as C is not 0 here. And the reason we exclude 0, obviously if you multiply 0 on both sides, it's fine. But it really doesn't help. It just cancels everything out. So we don't usually do 0 here. And then also we cannot divide by 0. So C could be a fraction in this case. And you want to make sure that you're also not dividing by 0 as well. So a couple things to watch out for when working with the multiplication property of inequality. So what it says here is that it is okay to multiply or divide both sides of the equation by the same number. Not 0 though. this will not affect the solution. Okay, so it's okay to do the same thing we did before. We can add, subtract, we can multiply, we can divide by the same number on both sides of the equation. With multiplication division, though, you don't want to do 0. We can't divide by 0. And multiplying by 0 just cancels everything out. So that's not helpful. But basically, we have the same rule here. So let's do some examples. So here I'm going to solve negative 3x is equal to 6. And again, for me personally, I just like to put that line just lightly down the center of my equation so that wherever the equal sign is, so I can see my two sides. And our goal for solving is to always get the variable by itself. So remember, when you see solve, you want to think about getting the variable alone. Okay, so we want the x by itself, so I have to get rid of this negative 3. So think about opposites. Negative 3 is being multiplied with the x, right? It's negative 3 times x. So the opposite of that is division. So I can get rid of a thing being multiplied by dividing. Now notice that when I'm dividing, I'm using the same sign. That's really important here because when this cancels, negative 3 divided by negative 3 is 1. Becomes the number 1. And 1 times x is still x. So we have a canceling here, but for a different reason. In the adding and subtracting examples, it canceled because we got a 0, and adding with 0 doesn't change anything. Here, when we're dividing, we're getting a canceling, but because we get a factor of 1, and then 1 times x is still x. So a little bit different. In here on the other side, I get negative 2. Okay, now we can check. So if I go back to my original equation and I plug in my answer, I get negative 3 times negative 2 equals 6, which of course is true. So this does check out. So let's do another example. Negative 15 equals negative 3y. Again, I like to just put that line lightly on my equal sign, and I want the y by itself. So I have a negative 3 being multiplied here. The opposite of multiplication is division. I didn't mean to use negative 3 twice, but you guys get the idea. Negative 3 divided by negative 3 is positive 1. So 1 times y is just y. And then negative 15 divided by negative 3 is 5. And again, you can check this as well. So you can just check this mentally. Negative 3 times 5 is negative 15. So this works out. All right, let's do one more example of multiplication here. So here I have 2n equals 20. Draw that little line. I want the n by itself. It's being multiplied with the 2, so the opposite is division. Notice I'm dividing by the exact number. 2 divided by 2 is 1. 1 times n is just n. And on the other side, 20 divided by 2 is 10. And you can see this checks out. 2 times 10 would be 20. So our answer here is correct. And let's just wrap up with a couple division examples. So let's say I have something like x over 3 equals negative 4. Now again, I want x to be by itself, but I have a problem. I have this divided by 3 stuck with my x. So what's the opposite of divide by 3? The opposite is multiply by 3. So we can cancel, right? If I multiply by 3, then that 3 over 3 just cancels out. And I just have to do it on both sides. So on the left here, I get x. Negative 4 times 3 is negative 12. And we can always check by going back to the original problem. And if I plug in x equals negative 12, I get negative 12 over 3 equals negative 4. And negative 12 divided by 3 is negative 4. So again, you really have to know your sign rules as well here. So it's something that if you need to keep reviewing them or you need to have a note card with you with those rules in front of you, that's fine. But you really want to have those drilled down so that you have them really automatic. All right, and let's do one more. So here, maybe I have n over, let's make it negative 10. Negative 10, I want to get that n by itself. So I'm dividing by negative 10 here. The way to cancel a division is to use multiplication. They're opposites. So that will cancel that out. And of course, don't forget to do it on both sides. So I have n is equal to negative 30. And you can check this as well. Negative 30 divided by negative 10 will be 3. So this is one that we can probably just do a mental check here. So this is our introduction to solving equations, and you have your one-step equations here. And your basic rules that we're going to be using. So practice with these first, and then when you're ready, we'll move on to the next video.